Hi, this is Module 7, Lesson 8, the practice problems. This is practicing those kind of the most challenging type of factoring quadratics. And so you got this down, you are going to be good to go. So first off, let's just practice filling in our sequences. This should be review at this point. We're going to start with number 1. Remember, if there's an arithmetic, we are going to subtract first. So 1875 minus 3 is 1872. And we're going to divide by however many jumps we have, which is 4. So 1872 divided by 4 is 468. So I'm going to add 468 each time. So 3 plus 468 is 471. Plus 468 is 939. Plus 468 is a 1,407. Okay, we had another 468, we'll get to 1875. Now remember, when it goes to the geometric now, we got to up our game a little and do a division. So 1875 divided by 3 is 625. And since I still have 1, 2, 3, 4, I need to know what times itself 4 times will get me 624. And that is actually 5. So we're going to do a times 5 on each of these. So 3 times 5 is 15, times 5 is 75, times 5 is 375, times 5 is 1875. All right, next. Let's do this one. So it's a subtract, a negatives. Negative 18 minus a negative 1458. So I'm really taking negative 18 plus 1458, and that is 1440. When I divide that by 4, I end up with a plus 360, which is true. If I add 360, I am going to get smaller into the negative. So 1458 plus 360 is a negative 1,098 plus 360, negative 738, plus 360 is a negative 378. All right, so now I'm actually going to do it opposite because I don't know necessarily what my fractions will end up being. So I'm going to do a negative 1458 divided by negative 18. So this actually will make this a division because I know I've got to get this smaller, but I just need to figure out what my fraction is in here. So 1458 divided by 18 gives me a positive 81. 4th root of 81 equals 3. So I'm actually going to divide by 3 or times 1/3 each time, whichever you want to look at it. So 1458 divided by 3 is a negative 486. Divided by 3 is a negative 162. Divided by 3 is a negative 54. Okay, divide by 3 again would get me the negative 18. All right, last one. 4 minus 1,024 is going to equal 1,020. And if I divide that by 1, 2, 3, 4, still looking at 4. 1020 divided by 4 is 255. Now, notice it's a negative 1,020, so I have a negative minus 255, which makes sense because I'm going from 1,024 all the way down to 4. So I should be subtracting. So that is 769 minus 255 is 514. Minus 255 is 259. Minus 255 would give me 4. So again, I'm going to do the first divided by the 5th. So it's going to be slightly off. So we're going to have a division. So I'm solving it to find what I'm dividing by, and then we'll switch it to a fraction. So 1,024 divided by 4 equals 256. So I want the fourth root of 256, which I believe is 4. So I'm going to divide by 4, or times 1/4. My common ratio would be times 1/4. Okay, so 1024, again, I need to get smaller, so it's got to be that divide or times a fraction. Divided by 4 is 256. Divided by 4 is 64. Divided by 4 is 16. Divided by 4 is 4. All right, so that should be a review. Now let's practice these equivalent expressions for our pictures. So here we're going to start with, let's do our factored form. I have 3x's plus 2. Oh, I said 3 and I wrote 3x's, wow, plus 2 right on one side, and I'm going to multiply that by 2x's plus 3. Now if I go by what I have total, 1, 2, 3, 4, 5, 6 x squareds, 3, 6, 9, 10, 11, 12, 13 x's, and I have 6 ones. Okay, next one. I have 2x's plus 2 on this side. This side I have 1, 2, 3, 1, 2, 3, 3x plus 3 gives me a total of 1, 2, 3, 4, 5, 6 x squared, 3, 6, 7, 8, 9, 10, 11, 12 x's plus 6 ones. Now my next one. I have 1, 2, 3, 4, 5, 6 x's plus 3 and x plus 2. And that gives me 6x squareds, 2, 4, 6, 8, 10, 12, 13, 14, 15 x's this time, plus 6 ones. All right, so they all contain, that we just did, all these that we just did, contain the same number of squares measuring x squared and 1 squared. What's different about them? So they all have 6x squared. They all have plus 6 for my c. So what's different? Well, the way they're arranged, right? Here I've got a 3 by 2. Here I have a 2 by 3. Here I have a 6 by 1. So my x squared boxes are arranged differently each time. How does the difference affect the quadratic expression that represents them? Well, the factored forms are different, right? Because we've got different sides multiplying. So the b value in standard form, in the trinomial, is different, right? So depending on how what the factors are, we know that the b changes because we're either adding or we're subtracting, or we're finding the different factors of 6 to be able to come up with 15. We're doing the different factors of 6 to get 12, different factors of 6 to get 13. So, all right, describe how the arrangement of the squares and the rectangles affects the factor form. Well, they're directly related because the factored form is directly connected to the dimensions of the rectangle, right? In the factored form is the dimensions of our rectangle. So that's going to affect that arrangement is going to affect the factored form. All right, now let's use it. Try it and use it. So here, we need to practice factoring when a is greater than 1. So let's go ahead and remember how we did this, right? We have to figure out the factors of 4, 1 and 4, 2 and 2, and then the factors of 2 are 1 and 2. So we know, what will we know first? Well, we don't know how many x squareds we have because we have 2 options. We do know one of these has to be a 1 and one has to be a 2 because there's only 2 options for our C. It's a minus, so I have to have a plus and a minus, but I don't know which one goes with which yet, so I can't put that in. So I need to figure out which combos are going to get me a plus 7 when I subtract them, but I'm using these. So let's do some space for work. Let's see if we can do it over here. So I'm going to start with 1 times something plus 4 times something. Well, if I do 4 times 2, no, 1 times 1, I need to have a positive 7. So let's minus the 1, because I know 4 times 2 is 8. 8 minus 1 would be 7. So I need the 4 times the 2, which means the 4x needs to come over here. The x needs to be over here. I need a negative 1, and I need a positive 2. So let's double check. 4 times 2 is 8, minus 1 is 7x. Negative 1 times positive 2 is a negative 2. So that one works. Let's try the next one. 2 has 1 and 2. 15 has 1 and 15, 3 and 5. Well, since I only have a 1 and a 2, I know that one of these has to be a 1x. One of them has to be a 2x. It's a subtraction, so I have one of each. So I don't know which one I'm going to need yet. So let's see. To get a 7, I don't know. Let's try 1 times what plus 2 times what. Well, if I do a 2 times 3, that's 6, but I need to have a negative. Let's do a, let's just try the 15 here and 1 here. So if I have a negative 15 plus 2, that's only 13. So that one won't work. All right, let's try the negative 5 and a 3 here. So negative 5 plus 6 is a negative 1. So that one doesn't work either. What did I do? 1 times, should we try the 3? Should we switch them? Plus 2 times 5. Okay, well that's 10. Okay, so if I do negative 10 plus 3, I get negative 7. So 2 times a negative 5, so that needs to be in the opposite one to get them to multiply. 3 times positive 3 times 1. Okay, so now I can look. Negative 5 times 2 is negative 10 plus 3 is negative 7. Negative 5 plus 3 is negative 15. All right, next one. Okay, so 6 has, I'm going to erase some of my work because I don't have much space on here for these. So 6 has 1, 6, 2, and 3. 3 just has 1 and 3. So I know I can put 1 and a 3 in here, but it's a minus, so I can't do a whole lot with that. All right, so let's try some combos. We know it's either 6 times 1. I need a positive 7, so subtracting to get a 7. Well, let's do 6 times 2, or no, 6 times something plus 1 times something. Well, if I do a 6 times 1, I get 6. Minus a 3, I'm not getting big enough. 6 times 3 is 18. Minus 1, that's not going to work. So let's try the 2 and 3. 2 times something plus 3 times something. Okay, well, 3 times 3 is 9. And if I need to subtract 2, there we go. We'll do a -1 and a +3. So that gives me 9 minus 2, which is a +7. So I need the 2 times the -1. So 2x goes over here, 3x goes over here. 2 times 3 is 6. 1 times 3 is -3. -2, +9. That one works. Okay, next one. 4 has 1 and 4, 2 and 2. 3 just has 1 and 3. Okay, so I have a 1 and a 3 for sure, and I need to get a -x. Well, the 1 and 3 and 4, let's try that one. 1 times something plus 4 times something. Well, if I do 4 times 1 and 1 times 3, that gives me 4 and 3, and I need to get a negative. So if I do a negative, negative with the second one, -1, that gives me -4 plus 3 is a -1. So 1 times 3, so I need to put the x over here and 4x over here, because it's 4 times that, times a -1 times a +3. Hopefully you're kind of following that process. I'm just trying to talk aloud so you can kind of hear what I'm thinking. Next row, let's do 4 has 1 and 4, 2 and 2. 5 has 1 and 5. So I can't do my first ones yet, but I can do my 1 and 5 since there's only the 2 options there. And it's subtraction, so I have to subtract, so I can't put my signs in. So I need to get up to 19. Well, I know 4 times 5 is 20. So let's do the 1 times plus 4 times. So if I do the 1 times 1 and 4 times 5, I'll get 20, but I need to subtract to get 19. So this would be a -1, this would be a +5. I need 4 times my +5 and 1 times my -1. So 20 minus 1 is 19. -1 times 5 is -5. 4 times 1 is 4 squared. Okay, next one. Okay, 1 and 3 over here, 1 and 8, 2 and 4. So this time I can do my x and I can do my 3x first. Ooh, this one's a plus, so I know they're both subtraction. Okay, so I need to subtract 2 factors to get 10. Well, I know if I do let's see, 3 and 2 get 6. So I'm actually going to do that over on this side, and I'll just have to erase if I need to. So 1 times something plus 3 times something. Well, I know 3 times 2 is 6, and then 1 times 4, if I use this one, then 4 plus 6 is 10. So I need the 1 times the 4 and the 3 times the 2. 6, 4, add them together, it's 10. There we go. All right, so this one, 1 and 2, 1 and 6, 2 and 3. Another subtraction. Those ones are trickier. Okay, so I can't do the x's, but I can do 1 in this one and 2 in this one. All right, so what combo can I do to get a positive x? So I need them close, but not quite. Well, 2 times 2 is 4, and 3 times 2 is 1, so that's 1 apart. So let's do 2 times something plus 3 times something. So if I do the 2 times 2 and the 3 times 1, I can have 4 and subtract 3 to get 1. So I need the 2 to be positive, the 1 to be negative, and I need to do 3x times the 1, 2x times the 2. Okay, -3 plus 4, positive. All right, next one, 1 and 3. Oh, 24's got a lot of combos here. 1 and 24, 2 and 12, 3, 8, 6, and 4. Oh boy. Okay, so this one we have our 3 and our x. It's a subtraction, so we have to subtract to get it. Okay. So I know it's 1 times something plus 3 times something. I need to get negative 14. Well, let's see. 3 times 8 is 24. That's 10 away. 3 times 6 is 18. Well, 1 times 4 is 4. 18 minus 4 gets me 14. So if I do, but I need a negative 14. So I should have a negative 6. So 3 times negative 6, 1 times a positive 4, 4, negative 18. That should work. Okay. So notice I'm just kind of using a little trial and error and some mental math to work through those. Okay, here. Oh, a plus. Good. The plus ones are a little nicer, I think. 2 and 5. Okay, so I need an x and a 2x plus, oh, they're both adding. Okay, so which of these factors can I add to get a 9? Well, 1 and 10, that's probably going to be too big. So if I do 1 times something plus 2 times something, 1 times 5, 2 times 2, 5 plus 4 is 9. Okay, so 2 times 2, opposite 1, and 1 times 5, that gets these two to multiply. Okay, next, 1 and 5, 1 and 6, 2 and 3. Okay, so I can do x, and I can do 5x. C is positive, B is positive, so they're both positive. I can add this time. Great. I need to get 31. Well, 5 times 6 is 30, so I'm going to go ahead and just do that over here. Actually, I might do it on this side. This one I have a little bit more room. So I'll do it over here. So 1 times something plus 5 times something. Well, 5 times 6 is 30, and the factor that goes with 6 is 1. So 30 plus 1 is 31. So 5 times 6, so 6 needs to be in the opposite. X times 1. Whew, we're getting there. All right, 1 and 5, 1 and 6, 2 and 3. Okay, so I can do 5x and x. That's a subtraction again. Okay, so I can't do anything of those. So I need to subtract to get 7. Well, 5 times 2 is 10. So let's try this one. 1 times, 5 times. Okay, so if I do 5 times 2, then I'd have to do 1 times 3. So let's see. 10 and 7, or 10 and 3. If I have 10 and I take away 3, I end up with a positive 7. So 1 times a negative 3, 5 times a positive 2. So that makes those guys multiply. All right, we're good. Next, 1 and 4, 2 and 2, 1 and 5. Okay, what do we know? Well, we know one of these is a 1, one of these is a 5, and opposite signs. Okay, subtracting to get 8. Well, 5 times 2 is 10. That's pretty close to 8. So let's try this. Let's try the 2 and 2. 2 times plus 2 times. So I said 2 times 5 is 10. And what goes with the 5 is a 1. 10 minus 2 gives me 8. So if I put the negative with the 1, I can do, so it's a 2x and a 2x. So those two are the same. But the 1 has to be a negative and the 5 has to be a positive. So 10x minus 2. All right, good. Last one, big finales. This just takes some time. Okay, so here, 3x squared. So I need a 1 and a 3. Oh, 75's got a lot. But the good news is I need to have something that's going to cancel out. So I know 3 times 25 is 75. So I wonder if those 3's will help me out in this case. Let's just try it. I have x and I have 3x. I hope I gave myself some enough space. Okay, so if I do 3 times something plus 1 times something, if I do 3 times, 1 times 25, that doesn't cancel out, does it? Because that's 9, and that's 25. Ah, what about, let's see, 15? Is it 15 times 5? Yep, 15 and 5. So let's try 15 and 5. 3 times 5 is 15. 1 times 15 is 15. So I need one of those to be negative. Doesn't matter? I don't think so. Negative 15 and 15. Okay, so x times 15. So I need the 15 over here. 3 times negative 5. So in this case, that's a lousy 5. Negative 15 plus 15 would cancel those out and then multiply. Okay. Here, 1 and 3, 1 and 2. Oh, look at that. We only have one factor to work with in each. So x, and they're both positive. So it's an x plus 3x plus. Who thought this kind would suddenly look easier? Okay, so what am I going to add together to get 7? Well, 3 times 2 plus 1 times 1, 6, 7. Perfect. All right. 1 and 4, 2 and 2, 1 and 5. Oh, another subtraction. Okay. So 1 is a 1, 1 is a 5. Need to add to get 8. No, subtract to get 8. Well, here's that 5 and 2 making 10 again. So if we do a 2 times 2 times, so 2 times 1 and 2 times 5, then here's 10. If I subtract 2, I get 8. So we can do 2x on both of these because we're using this one. And then I need to subtract 1 and add 5. Okay, that wasn't too bad. 1 and 2, 1 and 6, 2 and 3. Last one. We can do this. All right. So I know I have an x here and I have a 2x here. There's subtraction. Okay, so I need to get them so I have a positive 1. We had something similar before, I think, because we said 2 times 2 is 4, 3 times 1 is 3. So if I do the 1 times, it's 2 times. If I do 1 times 3 and 2 times 4, oh wait, 2 times 2, because 3 times 2 is 6. And I make this one negative. It's 4 minus 3. So 1 times negative 3, 2 times 2. Opposite. So they add. We did it. Nice job. All right. That's a lot of work on those guys. That's some good practice. If you've got those down, you can factor anything. All right, find the equation for the line of symmetry. So we have the x-intercepts. Write the equation of the line of symmetry. Well, the x-intercepts are going to be the line of symmetry is going to be exactly in the middle of them, right? So what's exactly between 3 and negative 3? Well, 0. So x equals 0. That's my line of symmetry. What's halfway between these guys? Well, let's see. Let's subtract them and divide by 2. Is that the best way to do it? Because if I go from plus 4, I end up at 0. If I go minus 4, I end up at 12. What's halfway between 0 and 12? 6. X equals 6. Okay, here. Again, let's go up 2 to get to 0. If I go down 2, I get to 3. What's halfway between 0 and 3? 1.5. Here. All right. Here I'm going to go let's see. Ooh, halfway between 3 and 14. Well, 14 plus, no, subtract. Subtract. 14 minus 3 is 11. Do I subtract or add? What do I want to do? 14, the distance between 14 and 3. Wow. All right. If I go down 2, I'm at -5. If I go up 2, I'm at -12. If I go down 2, I'm at -7. If I go up 2, I'm -10. Halfway between 10 and 7, you'd add and divide by 2. So we go up 1 is 9, or down 1's 9, up 1 is 8. Halfway between those two, x equals -8.5. There's a way to do it. Between 17 and 33. So let's try a little more mathematical. The average between 17 and 33 is 30. Oh, bump something again. 33 plus 17 is 50 divided by 2. X equals 25. Last one. Here we're going to go up. We'll do the math again. Add them together. 2.25 plus a negative 75 is actually minus 75. 0, 1.50, half of $1.50 is 75 cents, so it's 0.75. So 2 ways to think about it. You can either add them together and divide by 2, or you can think of, like, if I go down to 0, up to 0, whatever, where's the middle? All right. Thanks for joining us. That is all for today.